Hello and good day, Algebra. We are doing our third of 3 objectives on systems of equations. Our third method to solve them. Today, we're going to start talking about elimination. It just sounds fun. I will eliminate a variable is what ends up happening. But anyway, so let's look at this initial system here. 2x plus 5y equals 1, and 7x minus 8y equals 29. Now, we know that these two equations are kind of connected, right? They are part of a system, which means that x is going to be the same value in each of them, and y is going to be the same value in each of them, right? Right? Why is this not really set up for graphing? Because it's not in slope intercept form. We'd have to do extra work to put it there. Maybe our y-intercept works out evenly. It doesn't look like it will. That's going to complicate things. So graphing isn't really the best way to go here. Why is this not set up for substitution? Joey? Right. All 4 of our variable terms have a coefficient other than 1. We did do one like this with substitution, but it took a little bit of extra work. It wasn't the most fun to do, okay? And so this equation, this system here is set up for what's called elimination. And because x is the same value in both of them and y is the same value in both of them, don't write this down, but we can kind of combine these equations to say, well, if I've got 2 x's in the first one and 7 x's in the second one, total, I've really got 9 x's there, right? And then if I've got positive 5y in the first equation, negative 8y in the second one, really that works out to be negative 3y. I can just kind of combine those terms. And then if one equation equals 1, second one equals 29, the total value of the system is going to be 30, 1 plus 29. Follow me so far? Yes. But the problem with this is what? Writing this as one equation, doing what I did, what's the problem here? Gino? One is addition, one is subtraction. Not so much that. We can work around that. Remember when we talked about why we need systems in the first place? Violet? No? Rant? What? There's 2 variables. What I've done here was I took my system and I rewrote it as one equation with 2 variables. That's not very helpful. Okay? If you have 2 variables, you need 2 equations to solve. But it's this idea that leads us to the process of elimination. Because instead of combining these terms as they're written, if I can get one of the terms to eliminate itself, essentially give it a coefficient of 0, then I'm in business, okay? So step 1 here says write each equation in standard form. Done that. Step 2, multiply each term in one or both of the equations to get like coefficients for x or y. So I look at my coefficients to x. I have a 2 and a 7. Let's all just start with this one, okay? What is the least common multiple of 2 and 7? Thomas. That's greatest common factor. What's least common multiple of 2 and 7? Basically, what's the smallest number that I can make with a 2 and a 7? 14. So what I'm going to do here is I'm going to multiply every term in my top equation by 7. Because as long as I multiply all 3 terms, the value of my variables won't change. My coefficients change, my solution changes, but the values of the variables don't. And so this equation gets rewritten to be 14x, 2x times 7, plus 35y, 5 times 7, equals 7, 1 times 7. Okay? My bottom equation, I'm going to multiply every term in that one by 2. And the reason I'm doing this now is, remember, I want to get that coefficient to my x term the same. We chose 14 because it's the least common multiple of 2 and 7, and to get there, I had to multiply the top equation, everything by 7, the bottom equation, everything by 2. And that gives me 14x's, 2 times 7, minus 16y, negative 8 times 2, and equaling 58, 29 times 2. Everyone with me so far? Okay. What doing this does, by getting those like coefficients in front of that x term, I can now combine these equations with subtraction to get one equation with one variable to solve. Okay? If I subtract these equations, 14x's minus 14x's gives me 0x's. 35y minus negative 16y, that's one area you've got to be really close, watch closely here. You're subtracting, so you need that operation, but the 16 is negative, so it ends up being 35 plus 16, which is 51y. And 7 minus 58 is a negative 51. Right? Not 58 minus 7, 7 minus 58. And what I've just done here, by eliminating that x variable, is I now have one equation, because 0x is nothing, I can take it out of there. I have got positive 51y equals negative 51. I have one equation with one. I can't even write the simplest things today. 51y. I've got one equation with one variable to solve now. Okay? One equation with one variable to solve. This is called the elimination methods. Like I said, we've eliminated that x term to allow us to get where we are. It's also called, I like to call it ox and oi, because 0x looks kind of like the word ox. And if we found 0y, that's the word oi, and it's fun to say, ox and oi. Okay? Okay? But now here, what's our value? What's our value for y? 51 times y equals negative 51. Y equals negative 1. Right? Divide both sides by 51, and we get y equals negative 1. And just like with substitution, now that we know what y is, we can solve for the remaining variable by going back to our original equations, plugging in our value for y, and solving for x. So we'll just go to this top one here. Okay. Now that we know y is negative 1, we can rewrite this to be 2x plus 5 times negative 1 equals 1. Or 2x, 5 times negative 1 is a negative 5, equals 1. Add 5 to both sides. 2x equals 6, and x equals 3. Okay, Michael. Explain yourself. How? I've been accused of cheating, and I'm waiting for why. How? Okay. It's not cheating. What it is it's taking the characteristics of a system, that being that these two equations are connected, okay, and combining them in such a way that allows us to cancel out one of the variables to give us one equation with one variable to solve for. It's the same idea as what we're doing in substitution, right? We substitute that expression in to get one equation with one variable to solve for. This is just another method to do that. When substitution will get a little bit messy because all of our terms have coefficients to them, right? So it's just another way, another method to use when this equations present themselves. Any questions? Like you've done one of them, so if you're not understanding it, that's fine. Any questions I can help you with, though? Okay, let's go on to the ones on the bottom, those three on the bottom. Okay. My nifty tidbit there. Elimination makes solving systems a joy. Just combine the equations to get ox or oi. That's copyrighted, so you can't say that. Because that's copyrighted. I thought of it. So I copyrighted it. Or if you do, you gotta give me credit. Yes. What's that?
Did you actually copyright it or just put the symbol in?
Isn't that all you have to do to copyright something? Just put a symbol? No, there's more? What else do I gotta do?
Isn't there legal stuff that you have to do?
Isn't that what that means? Oh. Well, I guess it's, yes, it's copyrighted. I did all that stuff. All of it. Okay. So here we go. These three here. It says solve each system of equations using elimination. Show your work. This first one, we've got 6x plus 5y equals 22 and 6x plus 4y equals 20. Do we need to do any multiplication here? Why not? Because we already have those x coefficients the same anyway. So if our goal is to get ox or oi, getting ox here is rather simple. Am I going to be adding those equations to get 0x or subtracting? Subtracting, because 6x minus 6x equals 0x. Okay? We start with 6, we take 6 away, we've got 0x. 5y minus 4y is just 1y, or just y by itself. We like that. And 22 minus 20 equals 2. I probably didn't need to leave you this much space to work on this first one. Because once we get that 0x, we can take that out of there, and our equation is simply y equals 2. How do we get x? How do we get x? William? Does it matter which equation we plug it into? No. We'll go with the top one just because. Okay, so we can rewrite 6x plus 5y equals 22 to be 6x plus 5 times 2 equals 22. Because we solve for y, so we can plug that value in there. That is 6x plus 10 equals 22, or 6x equals 12. Once we move that 10 over to the other side. And then finally, x equals 12 divided by 6, which is 2. Okay, so 2, 2. If we were to graph them, that's where these two lines would intersect at 2, 2. And there we have it. Okay. Next one, negative 5x plus 12y equals 90. 7x plus 3y equals negative 27. Not in slope intercept form, so not really set up for graphing. Not really set up for substitution either. So we have this third elimination method. I have the option of either getting 0x or 0y, which means I can either get my coefficients to my x terms the same or the coefficients to my y terms the same. In this instance, what's easier? What's more efficient? To get my x terms the same or my y terms the same? Adam? The y terms, right? Because for my x terms, I'd have to go to 35, which involves multiplying both the equations. But to get 12y, I can get there in one step, right? So multiply the bottom equation by 4, and that's going to match up. It's going to be 12y. It's just like I have in the top one. Okay? Could you multiply them both and get 35x's? Sure. You'll get the same solution. But this is just a little bit more efficient. So our top equation doesn't change. 5x plus 12y equals 90. It's our bottom equation. We're multiplying everything by 4. And we get 28x plus 12y equals negative 108, I believe. Okay. So what operation are we going to be using here to cancel out those y's and get oi, 0y. Subtraction, right? If we add these equations, that means we'll take 12 plus 12, which is 24. That's not what we want, okay? We want to subtract these equations so that we get that 0y. There, 12 minus 12. Our x terms, negative 5 minus 28, gives us a negative 33x. Then here's where we got to be careful. 90 minus negative 108. Both the subtraction that we're doing to the system and the sign of that 108 need to be accounted for. 90 minus negative 108 is actually 90 plus 108, and that gives us positive 198. Okay? So that oi, the purpose it serves is so that we can eliminate it from the equation. And so we have negative 33x equals 198. Divide both sides by negative 33, and what do we get as a value for x? Negative 6. That sounds about right. Okay? To find the value for y, now that we know what x is, we can go back to either equation up on top. We'll stick with our theme and go with the first one here. So x is negative 6, which means we can rewrite this to be negative 5 times negative 6 plus 12y equals 90. Negative 5 times negative 6 plus 12y equals 90. This multiplication gives us 30 plus 12y equals 90. Subtract 30 from both sides. 12y equals 60. Divide both sides by 12. And y is 5. Isn't this a joy? Oxenoi? No? Someone's got to like it. Someone here. Yeah, they're out there. Yeah, yeah. Yeah, so here's the deal. So now that you know 3 methods to solve these, the method that you choose to do on the test, it doesn't really matter to me because all 3 get you to the same answer if you do it correctly. So for the graphing objective CO38, your equations will be given to you in slope intercept form. You'll be provided a coordinate plane. My intention is for you to graph them, but if you want to rewrite them in a standard form and use elimination, be my guest. Okay. On CO39 for substitution, they'll be set up for substitution. So one variable will already be isolated or have a coefficient of 1. If you want to rearrange it and use this, great. Okay. For PO40, if you want to rewrite these in slope intercept form and graph them, it'll get messy, but you could do it. If you want to isolate X or isolate Y and use substitution, it'll be messy, but you can do it. Okay. So the reason why this one is the PO is because now that you know all 3 methods, I really don't care which one you use to solve it, but one will be more efficient. So to answer your question, Michael, you can do anything you want as long as you get the correct answer, except for copying someone. That's illegal.
Use substitution on this one.
You can. It's messy because to get substitution, that means you have to get one of the variables by itself, and you're likely going to get fractions. But if you just want to do it out of spite, just to show me that you can do it, be my guest. You would not be the first. I know. Yep. Peter.
Did anybody violate that sign before?
No. Never. Sepa.
How do you use x to the conclusion of multiplying 4 by 4 again?
Sorry, ask it again.
When you multiply the
Why? Because I notice here that my options are either getting my x coefficient the same, which for my x values I have here, or x coefficients, negative 5 and 7, I'd have to get to 35, which means I'd multiply both equations by something, negative 5 by 7 and 7 by 5. But with my coefficients, my y terms, 3 and 12, 12 is already a multiple of 3, which means I only needed to multiply the bottom equation. 3 times 4 gives me 12 here, and that's why I multiplied by 4, to get that 12y to match what I had up in the top one. Okay? So looking at the third one, again, we've got options here. Okay? 4x minus 4y equals negative 20. Negative 10x plus 3y equals negative 20. We can either get 20 x's in both our top and bottom equations, or we can go for 12 y's again. Again, thinking about that least common multiple, 12 y's instead. Who would like to make the decision for the class? Blake? The y's? Very well. So, to get 12 here, in this case, we have to multiply both equations by something, right? We have to get 12 by multiplying by 3 in the top one, and then get 12 in the bottom one by multiplying everything by 4. Okay? So both equations get rewritten here. The top equation, 4x times 3 is 12x. Negative 4y times 3 is negative 12y. Negative 20 times 3 is negative 60. Make sure you're multiplying everything by 3 in the top equation. Yes?
Does it matter if it's negative? Like, shouldn't the top be negative 3 so that it could be?
It doesn't. It doesn't matter. That's a good thought. And I'll show you why it doesn't matter shortly here. In the bottom equation, negative 10 times 4 is a negative 40. I'm going to have to give myself some more space here. I'm going to erase some of this stuff. Negative 40. 3 times 4 is a positive 12. And negative 20 times 4 is a negative 80. Okay. Now, a good question was just asked, right? Because we said that we want to get the coefficients the same, but negative 12 and positive 12 aren't the same. But I said it didn't matter. Why does that not matter? How do we get to 0, Miranda? Yep. How we get to 0 from negative 12 and positive 12 is by adding instead of subtracting. Okay, we have that choice too. Here in the second one, when our signs were the same, we subtracted to get 0. When our signs are different, negative, positive, we simply add to get 0. So 12 plus negative 40, which is the same as 12 minus 40, that gives us negative 28x. Negative 12 plus 12 gives us oi, or 0y. And negative 60 plus negative 80, which is the same thing as negative 60 minus 80, is negative 140. We can eliminate that y variable. That's why we do what we do. And so we have negative 28x equals negative 140. Okay? One-step equation, divide both sides by negative 28. X equals 5. And then from there, we can go back to actually any of the 4 equations we have up above there are 2 original or the 2 that we rewrote to plug this in and solve for y. Yeah? Yes, I meant to get back to that earlier, but yes, we are going to write a definition. Let's finish this one and then we'll go back up. Okay. So sticking with our theme, let's go with the original first equation here. We now know that x is 5, so we can rewrite this to be 4 times 5 minus 4y equals negative 20, or 20 minus 4y equals negative 20. Or negative 4y equals negative 40. When we subtract 20 for both sides there. And we get y to equal positive 10. Okay. Now that you've seen 3 of them, any questions you might have? Raise your hand if you like the substitution method better. Raise your hand if you like the elimination method better. Raise your hand if you like them both so much that you just can't choose. Attaway. That's right. That's good. Okay. So what's our definition for the elimination method? Like I said, we go back up and we'd write a definition for it. How would you kind of describe this method? Annoying. Okay. It's more of an adjective. I'm kind of looking for some nouns here. How would you describe the elimination method? What are we doing? Not you people. My goodness. It's almost Valentine's Day. Show the love. Okay. The elimination method is rewriting one or both equations to get like coefficients for x or y No, I'm just pausing, taking a breath. To eliminate a variable term. Rewriting one or both equations to get like coefficients for x or y to eliminate a variable term. Okay. I was anticipating more questions, but is it making sense? I mean, at least, okay. What I'd like you to do for Tuesday is
Show your love. Give us a little homework.
Let's do.
The middle one. Just pick one hard one. Just pick the top two. Just pick a hard one.
Just the first two. Just the first two. Okay. Yeah, just the first two. All right. Anything else? Otherwise, new con has been assigned as well. If you want me to check over your math packet over the weekend, I've pushed the due date of that to Wednesday. So if you turn your math packet in today, you'll get it back Tuesday. You can make corrections and then turn it in Wednesday. So if you want that option, that's available. Otherwise, that's all I've got for you. So with gusto, that's how you math.